If you pitted an average modern human against an early Homo sapiens or a Neanderthal in a strength competition, who would win? It is a common belief that our ancestors possessed superhuman strength, adapting to a harsh world where survival depended entirely on physical prowess. But history and biology paint a more nuanced picture than simple brute force. To understand the true differences, we have to look closely at their bones, their muscles, and how their daily lives shaped their bodies. Let us dive into the science of ancestral strength. When researchers examine the fossilized skeletons of early humans, the first thing that stands out is their bone density. Neanderthals and early Homo sapiens had much thicker, more robust bones than we do today. The areas where muscles attached to the bone were larger and more pronounced, which strongly suggests they carried significantly more muscle mass. Their skeletal structures were built to withstand intense physical stress, indicating a lifestyle filled with high-impact activity. In contrast, modern human skeletons became noticeably lighter and more fragile over the last 10,000 years. This skeletal robusticity tells us a lot about their daily muscular demands. Early humans did not lift weights for leisure. Their entire lives were an intense, lifelong workout. Survival required hours of walking, running, carrying heavy animal carcasses, digging for tubers, and processing raw materials by hand. Every day involved tasks that forced their bodies to adapt by building dense muscle and bone. Modern life, even for a dedicated athlete, rarely replicates the constant, multi-directional physical stress that our ancestors faced from childhood through adulthood. Beyond sheer muscle volume, scientists have also looked at the types of muscle fibers our ancestors might have relied on. Human muscles are a mix of slow-twitch fibers, which are great for endurance, and fast-twitch fibers, which provide explosive power. Some genetic studies suggest that early humans, particularly Neanderthals, may have had a higher proportion of fast-twitch fibers. This would have given them incredible short-term power for wrestling large game or sprinting away from danger, though potentially at the cost of long-term cardiovascular efficiency. But why did we lose this raw physical strength over time? The answer lies in evolutionary trade-offs and energy efficiency. Muscle tissue is incredibly expensive for the body to maintain. It consumes a massive amount of calories even when you are resting. As early humans developed more advanced tools, sophisticated hunting strategies, and eventually agriculture, the need for sheer physical power decreased. Our ancestors started relying more on their brains and teamwork than on raw muscle, allowing our bodies to downsize to a more energy-efficient frame. Interestingly, the biggest difference between us and early humans might not be our genetic potential, but our lifestyle. Studies of modern hunter-gatherer populations show that while they are not superhuman, their physical fitness and functional strength often surpass the average sedentary office worker. Their bones are denser, and their endurance is remarkable. This suggests that modern humans still retain the genetic blueprint for great physical capability, but our comfortable environments simply do not trigger our bodies to build it. So, were early humans stronger than us? The evidence points to a definitive yes. An average early human or Neanderthal would almost certainly outmatch an average modern human in terms of raw power, bone durability, and functional strength. They were finely tuned products of a world that demanded physical excellence just to see the next day. While we have traded brute strength for cognitive efficiency and technological tools, understanding their physical legacy reminds us of the incredible resilience built into our shared human history.